And so we have a question. Calculate the mass of hydrated ethane dioic acid needed to prepare 5.0 dm cube of 0.15 mole per dm cube solution. All right, so the question is asking us to calculate mass. But before we go on to that, in the last video, we are going to look at the method of preparation of standard solution. So there are two methods of preparing, or two methods which we use to prepare standard solution. Number one is the weighing method, and another method we use in preparing standard solution is the dilution method. So you have the weighing method and then you have the dilution method. So looking at this, we're talking about mass, we're talking about weight. So for this is going to be the weighing method. And in solving questions on that weighing method in volumetric analysis, we use the formula number of moles equal to mass over molar mass. However, as you can see in the question, you're seeing dm cube. And each time you see dm cube, it represents volume. Each time you see cm cube, it also represents volume. So what we're going to be using here is that this same number of mole can be equal to concentration times volume. Right? Now this concentration is measured in mole, or have the unit mole per dm cube. Of course, volume could be either dm cube or cm cube. But for this case, volume is dm cube, mole per dm cube. So we're going to use dm cube. Another formula that we're going to likely use in question like this in volumetric analysis is the mass concentration. Mass concentration is equal to molar concentration times molar mass. Now, we said this concentration, remember, is from N. Okay, just going to write number of moles. So N here is number of moles. So we're going to have mole per dm cube. But this is mass and not mole. So we're going to have the unit of this as gram per dm cube. And this is going to be mole per dm cube. So looking at this question, what we have here is mole per dm cube. Hence, the formula we are going to be using to solve this question is this. Now, do not forget, we have number of mole equal to mass over molar mass. This same number of mole is equal to concentration times volume. So to abbreviate this, we just use N to represent number of moles. We use small m to represent mass. We use big M to represent molar mass. And then we use C to represent concentration, and then we use V to represent volume. You can equate any of these to themselves. So you can equate this to this, you can equate this to this, you can equate this to this. Any way you want to do it. So let's bring out the parameters that have been given in the question. The first parameter we have here is 5.0 of that solution. All right. So the first thing we have here is the volume of the solution. So we have V as 5.0 dm cube. Now, I told you that the unit mole per dm cube represents concentration. So what we're going to have for our concentration, we're going to have 0.105 mole per dm cube. And then this is the solution. This is the solution. This is the molar mass of the solution, 126 gram per mole. So we're going to represent that with our big M, 126 gram per mole. The question says find mass, small m. Remember our formula, N can be M over M. It can be concentration times volume. Now we have concentration, we have volume, we have big M. So we're going to equate this to this. So mass over molar mass equal to concentration times volume. Mass is what we are looking for. Molar mass is 126. Equal to concentration is 0.105. Your volume is 5. So 0.105 times 5 times 126. So we're going to multiply everything here to get our mass. So let's do that. 126 times 0.105 times 5. All right, so what we have is 66.15. So you can see we have 66.15 as our answer. So our mass is equal to 66.15. Now mass, what's mass measured in? Mass is measured in grams. So this is your answer. This is very easy. Questions on that volumetric analysis are very easy, and that's why they're like bonus question. And the good thing about it is that for your post-streaming your jam, one way to scale, one way to score really high is to be very fast. So when you see questions like this that are pretty easy, you don't have to spend all the time. You could solve it in 5 seconds. You could solve it in at most maximum of 10 seconds. You should be done with this question. So the reason why we took all this time is because we're trying to explain the whole concept. But if you see this in your exam, by the time you're saying five of this is volume, this is concentration, n equal to CV, you just use the calculator on your system and then you are done. All right, so let's look at the next method. In our next video, we're going to be looking at the dilution method and how we can solve questions under that.